All right, so this is our final project. His name is G.A.L.E. G.A.L.E actually stands for Ground-Based Actuating Legged Explorer, and he's just like a little quadruped robot with a remote-controlled arm on top. Basically, kind of all G.A.L.E is we have those two boards on top that send PWM signals to each of the servos, and each leg has two servos, which corresponds to like kind of alpha, beta angle, which when all the 8 pulse widths are sent at the same time, it kind of like makes a walking motion over a certain period, which I'm actually going to hand it off to Will in a second. He's going to go more in depth on that.
So here on the board, you should see an equation relating x, y, and alpha and beta with the sine and cosine terms. Um, this equation basically relates the xy position of the tip of the leg and the corresponding alpha and beta angles of the B and A segments of the leg with respect to the positive x-axis, if you think the origin at the intersection of capital A and capital B, right? And we use MATLAB symbolic logic to solve these equations. Simply, we give an xy value and we get an alpha and beta value back. And there are some offsets we incorporate due to the starting position of the legs, of the motors. But then we just translate those alpha and beta values into pulse width values and send those, using PWMs, send those to the servos.
All right, I just wanted to take a second to go over the wiring diagram now. So on the left, we have the two boards, which are connected to the servo shield. And the boards send, each of them send 4 PWM signals to the servo shield, and then the servo shield routes those signals to the actual servos. And then the servo shield itself is connected to a power supply. Because the board can't produce enough voltage or current to power all those servos, so we need an external power supply. And then the receiver, as well as the two servos for the claw, which on the bottom right, are also connected to the servo shield. All right, so just kind of here's a video of us going around showing Gal. That little black box is actually the receiver that controls the claw, and you can see the two boards, and there's Gal written on the LCD. And the next couple of videos that are going to play are just him walking.
Ready?
Yep.
Yeah.
Yeah, I know. Oh, also recognize I've talked to Gavin about what to do for the positive guys.
Yeah, it's just like, it's such a lot. Like, I actually am like looking at this project.
Go. Okay.
Still a limp, but
Which one do I reset now to get this?
this one.
Cool. No. So just to summarize, each board outputs 4 unique PWM signals. We use MATLAB to calculate 8 arrays, which correlate to 4 alphas and 4 betas. Each leg has 2 servos, each of which correlate to an alpha or a beta. Every 20 milliseconds, the code kind of increments through all the arrays and sends each servo a new pulse width, which translates to a walking motion. And then we kind of have the transmitter and receiver, which controls the 2 servos that work the claw. And then we also tried experimenting with it walking backwards, but I think the mass distribution was off, so it kind of hindered that. But yeah, that's a go.